Hi, this is Omer Azara, and this video is for Data620 Project 2. For this assignment, we're asked to identify a large two-node network dataset and apply to um, Osland method uh, to basically split the data. And we're also asked for information that we get from distant groups. For this project, I chose the scientific collaboration data from this repository right here. Um, so basically, there are a couple different data sets that are available here. They're all different and they have their own different characteristics. But the data that I'm choosing here, actually this one, because that's the one that actually the largest. You can look at it right here. And the specific data that I downloaded and then I use it basically weighted static one mode network, and there's the column that actually describes some of the joint papers that all the authors enrolled. Um, so for this project, I loaded a couple libraries. The major one, Networks X, and I use algorithms by partial, for plotting purposes, matplot library, pandas and numpys. Um, the first thing that I'm doing this for this project is basically reading the data directly. I'm getting the data. Basically, I do have the names for the data, the author, research, and then weight. And then I'm just printing here how it looks like it. We can see that the column name, the author, and then we can see the column name research, and how many research paper actually attributed by author, and then what is the weight of that of the research by the author. Um, the next thing that I'm doing is basically creating network research and an author that have involved in the research. We can see that here we do have, by just looking at the um, info here, we can see that 16,000 in notes and around like 78,000 edges in this graph object. By just having this data, the first thing that I want to do is basically looking at the distribution and to see distribution of the weight and see if I can get some sort of idea that I can just split the data, creating some sort of threshold to find out how I can split the data. Um, for that purposes, I can see that the number of the researchers and number of authors right here. We can see that closely. The distribution look like the range from 0 to 20. Um, so next step that I'm doing is basically and looking at the weights and counts and looking at the distribution of weights. Um, by just looking at here, as I said it before, I'm trying to understand what threshold we can use to split the data. Basic idea as a default. If I plot distribution weights, can I have some sort of idea that that I can split the data by looking at the distribution of weight. But I will reduce the size of network by um, Aslan method. The Aslan method can split up the whole network or the giant component in smaller components, which provides a simple and efficient means to investigate features of the network or group behaviors. The weights are the number of shared neighbors for an edge. Um, the weights in my data present the sum of joint papers that authors are contributed. Um, as I said before, the first thing that I'm looking at the distribution of weight. Second, I will isolate the biggest and smallest component of the graph, and I will apply the isolate method to put the authors and threshold in data frame. Um, I will reduce the size of network based on the weights. Um, the next thing that I'm doing is by just looking at this graph, I get to some idea that if I put the threshold between 5 to 10, maybe I can have it because most of the weights are just in the range of 0 to 5. I was 1 to the 5. Maybe I can put the threshold a little bit greater than 5. Maybe I can have idea about the relationship. But next thing that I'm doing is basically I'm creating the function for isolate method and trim edges. For this code actually I use it. It's coming from here from the social network analysis book chapter 4. Um, I can actually read it and I got the idea that I can use this code to understand to apply as a method. The code actually can be found here. Um, the next, what I'm doing basically, I'm creating weighted projected graph as I define it my object as a G, and then I'm looking at the raw data that I imported, and then look at the other the attribution from there, and then I can see that I have roughly 16,264 nodes and 31,900, roughly 32,000 edges. The next thing that I'm gonna do is basically having this as a method. Since I created the author graph, I'm gonna apply it to the as a method on that author graph, and then I'm gonna create the threshold and the graph the author list, and I'm gonna append them each nodes here. Um, the next thing we can just print it how threshold looks like, and then by looking at the connection between authors. So data frame, it says that if I use one threshold, I get 11,000 connections, and if I use the threshold 17, I got 265, and if I use the 33, I get 27. So the idea is basically, just using the one that has a, huge drop. That I'm going to use here 33 right here. The first I'm going to use the one the graph is showing me, using threshold uh, um, range between the 5 to 10, and then I'm going to use here 33 that I can see that here. If I use that, I can get to some idea how the other connections are. The question that we are asked basically, what can we infer about each of the distinct groups? For that reason, I'm going to look at it, the degrees and then degree centrality. I'm going to evaluate the important nodes by calculation degree and the degree of centrality. And the degree of a node is the number of neighbors that it has, and the degree centrality is the number of neighbors divided by all possible neighbors that could have. So by just looking at here and then do that as sort value. So basically I sorted by degree and degree centrality here. And then I can see that the author number 4034 and the author number 4474 has the highest degree value and then highest degree centrality. So these are my most important author numbers. So when we look at here, the top 10, I can see that here, the one 7315 has the third rank author number, and then 4673 is the fourth ranked author number here. The next thing that what I'm doing is basically I'm looking at I'm just giving an idea that how the distribution look like in centrality and look like in neighbors, and then by just looking at the degree and then degree centrality how it looks like here. The graph that I'm gonna plot it first to understand the relationship between authors. I'm using, as I said it before, if I look at the graph here, I'm using basically something in the range between 5 to 10. So I'm using just a value to get an idea how it looks like. So as you can see that, I can't get too much information of that. So this is not a good idea that using threshold as an 8. The next thing is basically, since I do have a data frame and then of the threshold, and then I'm going to use a 33 as a threshold and then try to see how the connections are look like here. So when I do that, actually, I got the idea that there are a couple author numbers, edges and notes that that they have a strong relationship and then weak relationship. Um, Highlighted, you know. Lines are says that two nodes have a really strong relationship. So by just looking at here, I can see that 4474 and 5489 has a really strong relationship, and also 1314 and 1315 has a strong relationship. And then on the other side, 1529 and 1530 has somewhere a good relationship. And I can see that 49350 and then 4034 has somewhere is a good relationship. The next thing that I'm then gonna do is basically, by just looking at this graph, I can get the idea of what authors have good relationship. But I want to verify with, um, looking at the get edge attributes, and then I'm gonna use the weight attribution here to see that if that is true. And then when I print the output here, I can see that how many weights are between the two nodes right here. So the first one, 4474. So as I said before, 4474 and 5489. 5489 has the strongest relationship between the two authors right here. We can see the weight is 84. And then next one is comes 7314 and 7315. And then as I said before, you can see already here, on 7314 and then 7315 has strong relationship, and then so on and so forth. We can have the actual printed, the showing how the weights between two nodes are look like it, which to verify what we see here. As a conclusion, we can see above the graph, author numbers, 4474 and then 5489, and then so on and so forth. They're printed author numbers here that has a strong relationship out of all the authors. As we can see in the above graph, not many authors have a strong relationship but just looking at this graph, we can get the idea of, and then use an Iceland method. I can just split the data by using threshold 33, rather than to cite by looking at the weight of distribution. Gives me a really good idea to understand the relationship between authors. Thank you.